Now, we have opened the conceptual assembly for the bottle quality control machine in NX Mechatronics Concept Designer, MCD. The 3D concept design is based on the first requirements from the customer. There is no mechatronic information yet. Therefore, we are open to use any 3D data from any computer-aided design CAD system. We add the mechatronic information to define the product, bottle, and NX reuses modeling information such as center of gravity and inertia to help save time and reduce errors. We define the collision objects to let it interact with other objects. When we start the simulation, the bottle clearly falls downwards and through the conveyor, as we have not yet set up the conveyor. Much like the bottle, we add mechatronic information on the main conveyor and define a transport surface so the virtual model will move the bottle in an identical manner as the real machine. The speed, acceleration, and other factors can be reused later in the actual PLC program. The simulation now shows the bottle is transported to the left side. What will happen at the end of the conveyor? Yes, the bottle overturns and falls. Similarly, we add the movement of the head in order to test the simulation. The head tests the bottle while following it while moving on the conveyor belt, so we would be done. But due to a new customer request, the machine must also be able to work with varying bottle heights. At the heart of every industrial machine is operational logic, and we can include this in the first simulation concept, not only the mechanics. This is what will also later become the automation. We now have changed the logic of this concept, so when the first shorter bottle is entering the machine, the height is determined and used for the entire batch. With mechanics and automation, by utilizing the digital twin model, you can simulate and iterate your first concepts to reduce issues in the actual machine. The simulation worked for the small bottles, but let's now also check a taller bottle. It does work, but the stopping and starting of the conveyor must be further improved to include a soft stop-start, as the taller bottle was unstable. Since we must remove a faulty product from the conveyor, the engineer checks the library of intelligent modules and finds a similar unit exists. Thus, we can simply reuse this entire pneumatic rejector unit. The unit can be added to the concept. The various dimensions can be chosen to fit in this concept, and all the mechatronic information can be reused as well, limiting design work and reducing errors. We also added an extra sensor to trigger the rejector unit. Now the engineer only needs to add some operations to control the logic of the rejector as required. After a new trigger is created, 2 more operations are added and linked to push in and out the pneumatic cylinder. After these small changes, we run the simulation to ensure everything works as planned. And yes, oh no, the cylinder touches the bottles, but not good enough. And the bottle continues to the end of the machine. The engineer did not see that error coming. But thanks to NX MCD, this issue will not appear in the actual machine. We can still fix it within this concept right away. The engineer checks, and the pusher is placed too far from the conveyor. The dimension values can be easily altered to move the pusher closer to the conveyor. Now the simulation shows the bad bottle is pushed off the conveyor. The concept is now being finalized. Therefore, the sizes of motors and drives must be determined. As all data is within this mechatronic concept, we can automatically calculate the forces, speed, and acceleration, and export for further detailed drive calculations. Sizer is the Siemens drive calculation tool and shows all available motor sizes with their characteristics. Instead of choosing the motor yourself, we now select the motor automatically based on the determined load from NX MCD.